Hi guys, welcome to our new video where we'll be learning about one of the questions from Leetcode, that is check if a matrix is an X matrix or not. Now the difficulty level for this question is easy. So let's first understand what is a X matrix. An X matrix is a matrix where all the elements on the diagonals on primary or the secondary diagonals are non-zero, and every other element other than the elements on the diagonal are zero. So let's say if I have a matrix of, let's say, 3 by 3, I'll create a matrix. Uh, so this is my matrix. So only elements that should be non-zero should be at these positions, and other elements like these should be 0. So this stands for any matrix which has a larger size or a smaller size as well. Now this is an X matrix. Now what constraints are given to us? Now in the constraint they have mentioned that the length of the grid is n, so number of rows and number of columns would remain same, and length can vary from 3 to 100. So the matrix can have minimum 3 or maximum 100 rows or columns. Any element in the matrix can range from 0 to 10 to the power 5. But over here we practically don't care about if the value is very large, we just care about if it is 0 or not 0. That's it. So only check that we'll do is if the value is 0 or not 0. Okay, now let's understand the algorithm behind this question, and what is primary and secondary diagonal. So if you guys are not aware of what is primary diagonal and what is secondary diagonal and how to traverse between these two diagonals, I would recommend you to click on the eye icon on the top right corner of your video. There I have linked one more question from the Leetcode where we had to calculate sum of all the elements on the diagonals. So there you will understand the basic concepts about what is a primary diagonal and what is a secondary diagonal, and how to identify whether the element belongs to any of the diagonal or not. Now let's straight away jump to the algorithm, understand the algorithm and the time complexity of the algorithm. So the algorithm for this question is very simple, straightforward, where we would be iterating two loops, one loop inside another loop. So first loop would be for I and second loop would be for j. And both of these loop would start from I is equal to 0 to I is equal to n minus 1, both inclusive. And for each iteration we would check if the element belongs to the diagonal and it has a value equal to 0, or if the element is not on the diagonal and the value is not equal to 0, then we would return false. That means if the element is on diagonal, it should be anything but not but 0, right? So if the value is 0, that means that is not a X matrix, definitely. And if the element does not belong to diagonal and the value is not equal to 0, that means anything apart from 0, then also that is not an X matrix. So it's just a two-step process and we are done. So this is a simple algorithm, and time complexity for this algorithm is definitely n square, because we have two loops running inside one another, and each of the loop would run from 0 to n minus 1. So that is why the time complexity is n square. Over here in this question we would not need any additional space because we are just checking if the value is 0 or not. So the space complexity remains constant. So space complexity is big O of 1. Now let's jump to the code and see how we are checking if the diagonal is not equal to 0 or equal to 0, or anything that is there in the algorithm. This is the code to check if the matrix is X matrix or not. And let's map this code with the algorithm that we just discussed. So in our algorithm, the first thing that we mentioned was we have to start iterating from 0 to n minus 1 for both I and j. So if you see, I have two loops running over here, I and j. Both of these loops start from 0 and go up to n, and that is less than n. That means the last value that would be valid is n minus 1. So 0 to n minus 1. So these two loops are running from 0 to n minus 1. So this is my step 1. Now for the second step, I was saying that if the element belongs to the diagonal, it should not be equal to 0. If it is 0, we would return false, right? So this is the logic. So this is for diagonal. So for diagonal, if you are still confused that how I am checking if the element is belonging to the primary or the secondary diagonal, I would recommend you to click on the eye icon and go and watch my video where we explained how to identify if the element is from any of the diagonal or not. So this is the condition basically for the primary diagonal, where each I and j should be equal, or if sum of I and j is equal to n minus 1, that means the element belongs to the diagonal. Now over here I am just checking if this condition matches, that means the element is from diagonal, and if the diagonal's element is equal to 0, that means I don't have to check any further. My case is resolved and I know that this is not an X matrix, so I would return a false. If let's say the element does not belong to the diagonal, we'll get into the else case. Now in else case, we have to check that if element should be equal to 0 or not. So what we have done is we have said that if the element does not equal to 0, is not equal to 0, we would return false. If neither of these false is met any time while iterating on these two loops of for I and j, that means there was no element that was contradicting to the fact of X matrix. That's why in the last we have returned true. So this is a simple code that is written in Go, but you can write the same logic in any language of your choice, whether C#, Java, Python, JavaScript, any language that you guys wish, but the logic that I have shown you should be same. So that's it for this video today, and in case you liked the video and it was helpful for you, please do not forget to like, share and subscribe to our YouTube channel. Also comment down below in case you want any particular question from Leetcode or Geeks for Geeks to be solved by us on Golang, or any other topics that you want us to cover for you guys using Golang. So go ahead and comment down below as much as you want, any topic on Golang, using Golang. We appreciate you guys to do that.